Alright, so can you see my screen, right? Fine. So in previous class, basically we discussed about that motion in the 1D. That motion we can explain by the generalized displacement equation, which is x equal to x naught v naught xt plus half of ax t square. So that would be basically that general displacement equation. Fine. So using that equation, I said that you can solve any type of motion, whether the particle is moving in a constant velocity, constant acceleration, or neither not, and also that 1D, 2D, and 3D motion, any type of motion we can explain by this equation. Alright, so first I'm going to talk about a situation like that. Say that in a scenario, say you are standing at the floor and one of your friend actually standing at the window. So you throw a ball towards your friend, so that after throwing your ball, say 1.5 seconds later, it was caught by your friend, and they give only information that distance between you and your friend is 4 meters. Now they ask you the two questions: what is the velocity it was thrown by you? So that's mean the initial velocity. And the second question is, what was the velocity just before it was caught by your friend? So that's mean that final velocity. They ask me these two questions: at what velocity did you throw the ball towards your friend? And second question is, what was the velocity before it was caught by your friend? Just before it was caught by your friend. Fine. To solve this equation, basically I'm going to use that general formula, but right now I will use in the vertical direction. So that means it's basically the free fall, which I can write my equation y equal to y naught v naught yt plus half of ayt square.
Sir, can you repeat the question, because I got cut off from the internet?
So see, the question is, uh, what was the initial velocity and what is the final velocity? So, or did you join the letter, or you just you just
No, sir. When you were discussing about the question, my net got cut off.
net is
You
cut
were
off.
saying that someone was on the window and
Yeah, the scenario
but I
is
couldn't.
okay. I got your point, but this is actually killing my time. So anyway, you should go through the recorded video again. So the
Okay, sir.
scenario is basically, I you throw a ball towards your friend which at the window. So after throwing 1.5 seconds later, it was caught by your friend, and the distance between you and your friend is the 4 meter. Now the question is, they ask, what is the initial velocity of the ball it was thrown by you, and what is the final velocity, the velocity of the ball just before it was caught by your friend.
Okay, sir.
Fine. So now, so this is the question I'm going to equation I'm going to use over here to solve this equation, solve this problem. So initial velocity would be over here, basically my v naught y, because this is actually the velocity, initial velocity along to the y direction. So that's why I have to find out that one. T, that's I know, that's given actually 1.5. The y is also given, why not I will choose z0, say I'll choose this is my origin over here right now. Then y naught is going to be basically the 0. Now what is ay? Ay is acceleration due to the gravity, right, which would be minus 9.8 meter per second. Remember this thing, this acceleration due to the gravity will be always minus 9.8 meter per second square. Whether you move to the upward direction or whether you move to the downward direction, it doesn't care about that. It would be always minus 9.8 meter per second square. Then if I plug in, I can find out, so this is 4, this is 0, v naught y, that's I want to find out, into 1.5 minus half into 9.8 into 1.5 square, right? Now I can find out that v naught y actually, so this is, if you do some calculation, then you will find out the v naught y actually 10.01 meter per second. So this should be actually basically that initial velocity. So at that velocity actually it was thrown by you. All right, now what would be that final velocity? So to find out that final velocity, basically you can use that formula, which is v equal to u plus at, but I will write down my way. It would be vy, final velocity in the y direction, which would be v naught y plus ayt, right, which is exactly the same equation. You write v equal to u plus at, but I write in that way. So fine, I am going to find out now vy. V naught y actually 10.01, right? I find out it's a 10.01 minus 9.8 into 1.5. So now if you plug in, you will find out that vy would be minus 4.69 meter per second. That would be actually the velocity, the final velocity. That means just before it was caught, the velocity of the ball was basically minus 4.69. Fine. Then what is the issue about this minus sign actually? What is telling this minus sign?
It's in the opposite direction of what we consider the positive direction.
Exactly. Right. So since we choose, this is actually our positive direction, but when it was caught, the ball velocity was in the downward direction. It means that when you throw, when it's moving to the upward direction, at that time your friend was unable to catch the ball, then it goes to the maximum point, then change its direction. When it's going to the downward direction, at that time it was caught by your friend. So that's why this minus sign actually telling you that the ball was caught when it's actually ball is basically descending its height. You understand? So that's why this equation actually tell you what is the real scenario behind the scene. All right, let's think about another way. Say you are standing at the top of a building, which is say that 15 meter, or you are standing at the first floor. Then from that floor you throw a ball towards upward direction, and say that is actually the trajectory. It goes to the upward at the maximum point, then it falls to the downward direction. You throw that ball, say that as the initial velocity 10 meter per second. Then the question is, how high does it goes? So that's when I can find out what is actually that y, how high does it goes. Second question is, when does it hit the ground? When does it hit the ground and with what velocity? So that's mean I want to also know that the final velocity when it's going to hit the ground. Now if you want to solve this one, this quotient basically, say I will use, I said that equation actually y equal to y naught plus v naught yt plus half of ay t square. Say only for simplification of this calculation, I choose the acceleration due to gravity is minus 10. I just take a round value, it's not a big deal. So only just for the calculation, I choose that one, 10 meter per second square. Then what I will write down this equation, if I want to solve how high does it goes, so that means I have to find out that how high it will go. It could be from here, from the top of this building, or you can also count down from that surface, right? First, one thing actually I know that when the ball would be actually at the maximum height or this point, what would be its instantaneous velocity?
0, sir.
It will be 0, right? Because
0.
it's changing its direction, right? It's changing its direction. So that's why at that point, the velocity at the peak point is going to be 0. Then I can find out the time of that one, how much time it will take to reach that maximum point. So how I'm going to find out that time? So first I will take the derivative of this equation, Vy, that would be basically dy divided by dt. I'm going to find out the instantaneous velocity. Then it would be basically this y naught would be 0. I'll find out v naught y, right, minus or plus, you can write, so it should be basically y t, right, which is a actually the v equal to u plus at formula you will find. Now I know when it is the maximum point, this would be 0, final velocity. Initial velocity I find out the 10, they give me 10 meter per second, and I also consider that ay is minus 10 for only for the simplification of the calculation. So then I'll find out t from there. So t would be basically 1 second. So that means if you throw that ball with 10 meter per second, and if the acceleration you consider which is 10 meter per second square, then 1 second later its velocity is going to be 0 at that point actually. Now if you want to find out that how high does it go, actually if I write this one, y equal to y naught plus v naught yt plus half of ayt square, then I'll plug in that value. Now I'll consider, I'm choosing from that from my origin is over here. So right now say that I'm considering the origin at the ground surface. Then I can say y naught would be 15 plus v naught y initial is the 10 minus is going to be the 5, right? Because ay I use the minus 10, so minus 10 divided by 2 is going to the 5, and t equal to 1 second I find out. I just plug in the value of t. Then I will find out it will be basically 20 meter.
20 meters, sir.
So that means it will go 20 meter from the surface of the ground, but from the top of the building it will travel the 5 meter because your initial height was 15 meter, right?
Yes, sir.
Fine. So this is will be answer of the question number 1. Now when does it hit the ground? If you want to solve that one and at what velocity, I know when it hit the ground, what would be displacement?
20
20
meter.
20 meter. It would be
Yes, sir.
Zero.
Displacement should be 20 meter.
no 20
Sir,
meter from
zero,
what?
sir.
No. Displacement should be 15 meter.
How?
Because from 5 meter should be 5 minus 5.
Then
So
you are
it will be
considering
zero.
no you are considering the origin over there. Then
Yes,
you
sir,
can say
yes,
that it will be the minus 15.
Yes, sir.
Right.
Minus 15. Yes, sir.
Yeah.
Yes, sir. Minus.
But I am choosing the origin over here right now because I mentioned that.
Sir,
Okay.
it is being thrown from here and it is coming from here. So y equal to eventually be 0, 0, sir, the whole case.
Yeah, depending on where actually you choose the origin.
Okay, sir.
Because I choose, this is my origin. So although I throw from that one, which is actually the 15 meter, why not? Initial displacement from my origin. But if
Yes,
you
sir.
choose the origin is over here, then your initial displacement would be the 0. Right?
Yes, sir.
And you will travel in that case minus 15 meter. Then why not would be basically the minus 15 meter. But since I choose the origin is over here, that's why its final displacement is 0. Initial displacement was plus 15 plus 10t minus 5t square. I choose again ay actually the 10 minus 10 meter per second square. Now it's a quadratic equation. You can solve this one. If you solve, then you will find out the two value. One, you will find out the minus 1, another will be basically the 3. So I will neglect this minus 1 time because right that we are not considering the time cannot be negative over here. So we will find out that t will be 3 seconds. So that's mean after 3 seconds it will strike the ground. And what velocity? You can find out that one. So you can write down, say that either this equation v equal to u plus at, or I should write vy actually v naught y plus ayt, this equation, or you can use that equation also, v square. I will write it that way, vy square would be v naught y square minus 2ay, or plus I should write down the plus because that would be depend on the sign. If you solve, then you will, if you any equation you use, you will find out the v would be basically 20 meter per second. So that would be the case actually. That's how actually we can use those equation to solve this type of motion. All right, now let's talk about basically two-dimensional motion actually, which is actually, you know, that the projectile motion. One thing guys, I'm going to say that basically it would be not possible because I have to finish my lecture somehow today of this motion. Probably I'll be not able to do all the problem in this live session. What I'm going to do actually, I'll try to do 1 or 2 problem over here. Then I will the rest of the problem I'm going to basically record it for you, and that I will upload it into YouTube, my YouTube channel actually. So you can access those solving problem of all of my lectures so from there. So that's why
When you will upload that? Sir?
that actually it will be, you can do one thing actually. I'm not actually just saying this in favor of my, basically I'm saying for you basically. I'm
sir.
going to do
Yes, sir. Yes, sir.
do one thing basically, just subscribe that channel. Whenever I'm going to upload that one, you will get
alright,
that
sir.
automatically notification,
sir.
right?
Okay, sir. Okay, sir.
Because if I want to solve all the problem over here, then it would be tough to go through the lecture or the topics properly. I cannot go in that depth actually, but I want to go that in that depth of the topics. But for that one, then it would be tough for me to solve more problem in this live session, because definitely it will be, I want to also maintain in when I'm going to go back to my campus or my in-person class. Hopefully we are going back to in our class. So in that case, yeah, it will be difficult. Yeah, I feel that, but in the in-person class, it will be also is time consuming. Whatever I can deliver in this online class, in the in-person class, it is also would be for tough for me. So there is some
Yes, sir.
yeah. So there will be some issue
Yes.
into in-person classes. This is because this is at least
Because,
the
sir, we are
two.
going there suddenly, sir.
Yeah, it is actually the 2 years back actually. So I don't know what would be the situation in
sir.
my classes actually. So that's why
Sir,
to
even we
overcome
forgot, sir.
to overcome
many
this issue
things.
actually, that definitely you should. I will continue this YouTube channel. So it will be help a lot actually. I hope so actually. So that's why my request would be, please connect it to that YouTube channel somehow. So because most of the time I want to do a lot of problem in my class, but it's sometimes time consuming actually. So that's why sometimes I cannot do all the problem in the classes. So I take a plan actually for that one. I will record it or those problem, and I'll upload it into that YouTube channel, so that you can access anytime you want.
Thank you so much, sir. We'll do that, sir.
Sir, are you recording this?
Yeah, I'm recording this. Why?
না usually একটা notification আসে।
No. Basically, that for that was for as far I know for Google,
The
right?
Google Meet, sir.
Google
Yes,
Meet.
sir.
But the Google Meet, that unfortunately they turned off their option for us. I don't know why it's so actually. So that's why I'm using the third-party software, which is basically the OBS. Right now, I'm using the OBS.
Oh.
All right,
Sir,
let's.
can you provide your YouTube channel link?
Oh God. All right, I'll provide that after the class because I
The
do
channel,
not.
the Slack, sir, where sir uploads the video. So isn't it at that channel,
Yeah,
sir?
exactly the same channel. Yeah, click
Yes,
from
sir.
that link and you will find out that channel, which is fundamental of physics. I give the name of that channel.
Oh, okay, sir.
Thank you so much, sir.
All right, so it's basically the projectile motion is a two-dimensional version of free fall. You can say that it is a basically the special kind of two-dimensional motion under the influence of the gravity. We say in that way. So projectile is anybody that is actually given an initial velocity and then follow a path determined by entirely by the effect of the gravitational acceleration and air resistance. But most of the case actually we neglect that air resistance over here. So the path followed by that projectile actually we call is a trajectory, right? Say for example, if I draw it for you, say this is a Cartesian, your familiar Cartesian coordinate system. Say this is my x right now, this is my y axis. If I projected a particle in that direction with a initial velocity v and making an angle, say that theta, and that will follow that path, right? That path actually we say this is basically trajectory. And when you talk about this case, actually right now it's a two-dimensional motion. Remember, this is the main point for this motion. When you throw a particle into that air, then the particle has two types of acceleration. One in the x direction, another would be in the y direction. Acceleration along to the x direction will be 0 meter per second square, and acceleration along to the y direction would be minus 9.8 meter per second square z hat. This is a very important thing for this motion. This is the only difference between this any type of motion and this projectile motion. That thing actually going to be differentiate this motion. Look at this. This system has two types of motion. One is moving at a constant velocity, which is in the x direction because there is no acceleration, right? And one in the y direction, the particle moves at a constant acceleration. The same particle, it has two characteristics. In one direction, it moves at a constant velocity. That's why its acceleration is 0. And in the vertical direction or the y direction, it's moved at a constant acceleration. Why? When you throw that particle, after throwing that particle, the only force on the particle act in the vertical direction, which is gravitational force. If you are very close to the net, to the earth's surface, there is a point I mentioned this one actually. If you are very close to the earth's surface, then this is true. Otherwise, if you are very far away from earth, then the direction of this gravitational force would be in the different direction actually. We'll talk about this thing when I am going to talk about the gravity. So that's why this acceleration is always would be downward, which is ay. Sometime actually you guys use, not you actually, you have instruct to use, I don't know actually, so why they do that actually. Sometimes say that when it goes to the upward, they will take the positive. When it goes to the downward, they take it the negative, or vice versa. Someone say it the opposite, sir. When it goes to the upward, they say that A is negative, minus 9.8. When it comes to the downward, then they say that A is plus 9.8. But I do not know actually why they flip their direction. I'm saying this one basically, I'm not changing my direction at all, because once you throw that particle into the air, the force on that particle by the gravitational force is directly to the downward, because right now you are very close to the earth's surface, right? Please try to understand this thing. Actually, if you don't understand, you can raise your point over here. Otherwise, you will have a confusion. If you cannot overcome this confusion, then it will be big trouble for you to solve the problem from this chapter or these topics. So that's why I will say this particle has the acceleration only towards the vertical direction, which is the downward, because I choose this is my upward direction. Whether you goes to the upward direction or you comes to the downward direction, it doesn't care about you. Force is always is the downward on you by the gravity. So that's why, since the force is the downward, then the acceleration will be always downward. So that's why I write down the AY is minus 9.8 meter per second square. If I consider the gravity, I will always use the minus. It doesn't care about whether I am going to the upward direction or the downward direction. Acceleration due to the gravity would be always negative if you are very close to the earth's surface. When you are doing this experiment at the surface of the earth, so definitely the acceleration will be always negative. And then we can characterize this motion actually. So one thing I can say, this particle or this system has a two type of motion. One is moves at a constant velocity, and it also moves at a constant acceleration. It will move at the constant velocity along to the x direction, and it will move at a constant acceleration along to the vertical direction. Same particle, it has the two different characteristics. That's why it is a very special case. Very interesting thing. All right. Now, if I want to draw this motion, say I want to draw in a bigger scale for you. So this is my axis, and this is my x-axis, this is my y-axis. Say I projected a particle in the air, and that follow that trajectory. So I give its initial velocity, say this is your initial velocity, is a v naught, it makes an angle, the theta. If I take that component of this velocity, this one v naught x, which is the initial velocity along to the x direction, I know how to take the component of a vector, right? That's the thing we talk about in the vector chapter. This is v naught y. Now this v naught x, I can say throughout its journey it will be remain same. V naught x over here, v naught x over here, at the top it will be v naught x, at the bottom over here it will be v naught x, it will be also v naught x, it will be also v naught x. It will be remain same throughout its journey. Why? I know that along to the x direction it's moved at a constant velocity because acceleration is 0. So that's why throughout its journey this v naught x is not going to change. The change would be only in the vertical direction because it is moving at a constant acceleration. When you throw, gradually it will decrease that velocity. So that's why I try to draw this length, this smaller. When you moving to that direction, the velocity is gradually going to be the decreased. When it at the top point, your v naught y is going to be the 0. At the top point,
So
right?
Are
Yep.
these happening because of the first law of Newton?
No, it's basically of this gravitational force. Actually, it's going to the in the opposite
Yes,
direction
sir.
of that force.
That's why I was saying, sir.
Yeah, yeah.
First law of Newton.
Yeah,
Thank
yeah.
you, sir.
Yeah. So, yeah, you can say that everything actually there you can describe, because the Newton's second law is a consequence of the first law. I'll talk about this thing when I'm talking about the Newton's law of motion.
Yes, sir. Yes, sir. Of course, sir.
So fine. So after crossing that point, right now your velocity would be downward direction. V naught y, you will find out. Say I take another point, v naught x over there. Gradually it will increase that velocity v naught y, it would be also that v naught y. Now look at this. When you throw that particle, I said along to the x direction, it moves at a constant velocity. So that's why the v naught x is not changing, it will be remain same, but the v naught y is changing. Well, it's moving to the upward direction, its velocity is gradually decreasing, and at the top point its velocity is 0, only the vertical component is 0. It doesn't mean that the total velocity is 0 for this case. Only the vertical component is 0 when you throw in that way. Just right after that maximum point, the velocity will change its direction. It will gradually again increase, and it will strike that surface with exactly the same velocity whatever it was thrown by from that point, if we neglect the air resistance. Remember, this is the ideal case actually. If you neglect the air resistance, whatever the velocity it was thrown from that point, it will also strike at the same velocity over here. Alright. Now what will happen, say if I say that increase that one, what will be that velocity? Will it be same over here, or it will increase, or it will decrease? What do you think? Say v naught x will be remain same. It's not changing because in the x direction it has no acceleration. So that's why it will be again remain same. V naught x velocity along to the horizontal direction will be remain same again over here. But the vertical component, definitely it is going to be the increase, because right now it's moving to in the direction of that force, the gravitational force. It will be accelerated definitely towards that direction of the force. Definitely the force velocity will be definitely increase over here. So that's why this velocity will be much higher than it was at the surface. So I should draw this bigger length actually. It would be bigger. Alright, so this is actually the characteristics we define. From this analogy, I'm going to talk about some characteristics. Say, if we consider this, if we neglect that air resistance, I can say the time it will take to reach from the bottom point to top point, it will take exactly the same time from top to the bottom time. So that's mean I can say, I can write say Vy equal to the 0 at top point, only the Vy, but the total velocity in that case, if you write down the total velocity Vx I hat plus Vy z hat, you will find out only that Vxi at the top point, right? Although that vertical component is 0, but there is present also the horizontal component for this projectile motion or two-dimensional motion. But if you throw in the vertical direction only, if you throw to the upward at the top point, your total velocity is 0, because at that point we have only that vertical velocity, there is no horizontal velocity at all. Fine, I can say second one, T up, the time it take to reach at the top point, it will be equal to the T down, right? So that's mean whatever the time it will take to reach from that point, this one, from say that point to that point, which I say is the T up, time to take to reach at the top point, and it will take exactly the same time to reach at the down point if the height are level. If the height are level. But if I say from there to that point, it's not going to be the same, because right now it's traveling some vertical displacement also over here. You can say that this will be the true if the vertical displacement of the particle is 0. T up equal to T down when y equal to 0. Y means total vertical displacement is 0. Then we can say this one. Then what will be the total flight of time? Or I can write is a T total. You say that time of flight actually it would be 2T up. Right. Third one, the range you define, it would be same height, or you can say when again y equal to 0, vertical displacement is 0. Why I am saying that, say when the range you define, actually you throw a particle, is follow that trajectory, then you say that that displacement is basically the range, right? Am I right, guys?
Yes, sir.
What if,
Yes, sir.
say if you throw a particle from there and strike that at the top of a building, then this horizontal displacement is not going to be the range, or vice versa. If you throw from there and it strike that surface, then you cannot say that this one is the range. For the range, the particle vertical displacement must be the 0, which is that I write the y actually the 0. You can say the range only if the particle are in the same height before it was thrown and when it was strike the ground. I write in that way actually. If the vertical displacement is 0, then I can say it would be basically the range, otherwise not. Remember this point. This is one more important point actually. And instead of saying the range, I say it is basically the horizontal displacement. I will find out that equation. Don't worry about that. I'm going to show you. I'm not going to actually recommended you to memorize this equation. You can use only this generalized displacement equation to solve this equation. And let's come to the fourth point actually. Theta is decreases as height is increases, which is actually if you goes to the upward direction, your theta will be decreases. Why? Because that theta you are going to find out probably using that equation, tan inverse Vy divided by Vx. Your Vx remains same, your Vy is gradually decreasing, so that's why your theta will be decreasing. It means that when you throw a particle towards the upward direction, your angle, that angle actually gradually will be decreases, and that theta at the top point basically makes it 0 actually, because your Vy actually the 0 over here. And opposite will be happen when it's reverse the direction, gradually in that case actually theta will be increases while height is decreases. And the same height, say for that whatever the theta over here, it will be exactly the same theta in the opposite when it's basically the descending the particle. Well, that's mean when it's basically coming to the downward direction. These are the basic characteristics of this projectile motion. Now come to that equation actually you memorize. I'm going to show you that equation would be also could be derived from this equation. Look at this. I'm going to show you that over here. So if I throw that particle into, say this is my x, this is my y, I thrown that particle with that initial velocity making an angle theta, then this follow this trajectory. Alright, so if this follow that trajectory, then I can say this is my v0 x and this is my v0 y, the initial velocity. I can find out that v0 x, this v0 x is going to be v0 cos theta and v0 y would be v0 sin theta, right? I write down cos of 90 degree minus theta because this angle is basically 90 degree over here. Fine, that's great. Now it has two type of equation of motion over here. So first I'll write for the x direction would be x naught plus v naught xt plus half of axt square. I know along to the x direction the particle moves at a constant velocity, so that's why this acceleration will be the 0, and I choose this is my also that origin, so that's why this x naught is going to be the 0. Then I will find out this would be x would be v naught x into t, right? And this t actually that total flight of time of that case actually. Then I can write down this x would be v naught cos theta into t. So that would be the equation of motion in the horizontal direction of this, in the case of projectile motion or two-dimensional motion over here. Now what about for the y direction? For the y direction I will write y equal to y naught plus v naught yt plus half of ayt square, right? Now I choose that this is my origin, so that's why I say the initial vertical displacement is 0. I can write y would be v naught y, I can write v naught sin theta t minus half of g t square, right. So, this would be basically the equation of motion in the vertical direction. From this equation I can find out one more equation, which is I can, if I take the derivative, it would be Vy, that's going to be V naught sin theta minus gt. If you take the first time derivative of this equation, you will find out this one, which is the velocity at any time in the vertical direction. But the velocity in the x direction is remains same, which is Vx would be V naught cos theta, is not changing because it moves at a constant velocity along to the horizontal direction, but the vertical direction is moves at a constant acceleration. So, that is why your velocity equation will be that one. Fine. Now, I am going to find out, say if you ask me how much time it will take to reach at the maximum point, right. Say the time to reach at maximum point, which you define T up. So, I know if the particle reach at the maximum point, then I know its vertical velocity Vy must be going to the 0, right. Then I know the Vy actually V naught sin theta minus gt equal to the 0, then I can find out this is a T up, that would be V naught sin theta divided by g. So, this is actually equation you memorize probably, T up actually V naught sin theta divided by g. That's fine, that's going to be the work if the situation is idle, but sometime it's not going to be the same, it will be different. If this angle going to be the different, instead of making the angle with the horizontal direction, if it is create the vertical direction in the angle, it could be, right. Then this equation is not going to work for you, but I write down this equation from only from that equation velocity, or I can write down only for this displacement equation in the vertical direction. From that one I can also find out that time to reach actually the maximum height, to find out that one if I just know the height. Then the T down I am doing for idle situation actually, T down would be also the equal, right, V naught sin theta divided by g. Then the time of flight, you define the time of flight actually the total time it take, or the time it was in the flying mode actually. So, that is why we say that time of flight. You can write Tf. So, time of flight it will be the 2T up, which is actually 2 V naught sin theta divided by g. These are the equation guys you memorize, but I am just showing you how you can find out that one. You do not have to memorize this procedure, or you don't have to do this calculation. I will show you how to solve this problem actually just after these topics. Fine. Now, if I want to find out what is the maximum height, that one I can find out using my displacement equation, y equal to y naught v naught yt plus half of a yt square. I know that t time to reach at the maximum point, I find out that time, which is the T up. I know the V naught y, which is V naught sin theta, and the T is actually V naught sin theta divided by g, right, that I find out from this equation. This is actually my T up or the T down equation. I am just plugging in that one over here, minus half of g t square would be V naught sin theta divided by g square, right. Now, if you plug in this one, so this would be V naught square sin square theta divided by g minus half of V naught square sin square theta divided by g, because g square g will be cancelled out. I will find out this one. Now, I can factor out this quantity. It would be V naught square sin square theta divided by g. It would be 1 minus half. I will find out in that case half V naught square sin square theta divided by twice g. That is actually your maximum height equation you memorize. You write down probably h max V naught square sin square theta divided by twice g. So, this is actually your maximum height equation. That comes from that equation I said you, from this displacement equation. I will never write down to find out the maximum equation that one. I will write down always this equation from this equation. I will solve this maximum height. So that's why I'm not recommended you guys please memorize this equation. You don't have to memorize this one because this is a very special case. This is the for ideal case you are going to work. But if the situation is not ideal, say if I throw a particle from there and it goes and strike that point. So now if I ask you that height, will it be maximum height? You cannot
No,
say
sir,
that.
because no, sir.
It's not the ideal situation. In that case, this equation is not going to work for you. But that
Sir, which
equation,
equation will be work for these cases, sir?
yeah,
I
this
forgot.
equation, only
Wait,
that equation, only that equation is always I can
these
use.
equations, sir.
Yeah, generalized displacement equation, always going to work for you.
Okay, thank you so much, sir.
This this maximum height equation you can find another way actually, depending on the information, or sometimes we use this equation which is actually vy square v naught y square minus 2gy. You can also find out. In that case, this one would be 0 final velocity when it is the maximum point, right? I know. Then this is actually v naught sine theta square minus 2gy equal to y would be in that case v naught square sine square theta divided by twice g. I can use that equation also to find out the maximum height. So you can find out in that way. Fine. So now what about the range actually? Range, instead of saying that I say it is a horizontal displacement, that would be the better to say. Say that I write down horizontal displacement instead of saying the range, because range is very special case. When the vertical displacement is 0, then you can say the range, otherwise not. So that's why it's better to say the horizontal displacement, which should be always true. So this one in the horizontal displacement, I know it moves at a constant velocity, so that's why my equation would be x would be v naught x into t, or this x v naught x actually v naught cos theta into t. That actually t actually your time of flight mode, whether it could be say that this total time, or say if you throw this, whatever the time it will take from reach from here to here, that time is indicating that one. And for general case, for this ideal situation, we know this is the time of flight actually, t actually 2 v naught sine theta divided by g, right, which is the double of your time of off in the ideal situation. Then you write v naught cos theta into 2 v naught sine theta divided by g. I'll find out x would be 2 v naught square sine theta cos theta divided by it would be g. It would be g. Then I can find out x would be basically v naught square 2 sine theta cos theta basically is sine of 2 theta divided by g, right? So that would be actually your horizontal displacement, or range max, probably range actually, range equation you memorize. For the max, we know that this theta must be the 45. In that case, this becomes sine 2 theta become actually the 90, and sine 90 basically the 1. So that's why you write down x max actually v naught square divided by g, which is the maximum horizontal displacement could be. If the theta is 45, in that case, that would be that case. These are the case actually. Look at this. Whatever the situation I talk over here, only I use my that generalized displacement equation. Let's think about a case. I'm going to discuss a issue over here. Say you are targeting a particle. Say you throw a particle horizontally, or you can use the dart board actually. You throw your dart towards that point. So this is your target point, but unfortunately say your dart is stuck over here, which is actually, I can say below is say 1.9 centimeter below from your target point. and they give us only one information basically, which is the distance from that point to that point is 30 meter. Now the question they ask you, what is that time of flight? You say that the question is time of flight, total time actually in the flight mode. This is the first question. And second question, what was that initial velocity v naught x? These are the two questions. That's mean at what velocity it was thrown by you, and what is the time of flight? Time of flight means how much time it was in the flying mode. So that's mean before start from that point and before you strike that point. That is actually that was actually time of flight for this dart, right? Because in that time it was in the flying mode. So that's why you say there is a time of flight. Now if you want to use your time of flight equation that I'm sorry, that you memorize, which is TF, I write to V naught sine theta divided by G. That's your time of flight equation, right? Am I right? Let me check that. Sometimes I forget because I do not memorize that one. Yeah, 2 V naught sine theta divided by G, which is. Now what with that? If I want to plug in this equation over here, what is the theta over here?
That theta is 0 here.
0. Then time of flight would be what? Sin 0 is 0. Sin 0 is 0, right? Your time of flight is going to be the 0 right now. Does it make sense? It cannot be explained in this situation. So that's why this equation is not appropriate for this case. This is a very special kind of equation. I said it again. This formula is not going to always work for you. It will be work only for the ideal situation. It's not going to work for in my real life situation. It would be if the situation is the ideal life, then it could also work in the real life. Otherwise not. That's why neglect this equation. This is a very special kind of case. Why I will learn only the special kind? I have to deal with the general situation, which always try to understand the general situation. If you can solve the generalized problem, you can solve the special kind of those. But the problem is that we teach our child only for the special kind. We are making our children special. That special is actual not different meaning actually. I'm sorry to say. Do not think anything in a special way. If you know the general thing, definitely you can solve the special kind. But if you only can handle the special situation, you will never handle the general situation. That's why I always encourage my students, please try to understand in generalized way. If you can generalize any system, you can definitely come to your special kind of situation. Alright, then how I'm going to solve this one? Fine, I can use this equation, y equal to
So y is equal to y naught
not
plus
v naught
yes, sir.
yt
Yes, sir.
plus half of ayt square, right? Because it is basically starting that point. So this is my equation. I know my ay, which is minus 9.8 meter per second square. I neglect that direction over here. Fine. Then v naught y, what is that? V naught y actually the initial velocity along the vertical direction.
Sir, is it minus 9.8 or plus 9.8?
It's in the minus. Ay acceleration will be always minus 9.8. What would be the v naught y? V naught y actually the initial velocity in the vertical direction. That is going to be the 0 over here, because I thrown that dart towards the horizontal direction, right? And I also choose, say that this y naught would be 0, because I choose that is my origin over here. I choose this is my origin. That's why the y naught is 0, and the y, which is final displacement, and it should be minus 1.9 into 10 to the minus 2 meter, because it was in centimeter, 1.9 centimeter. I convert that to into the meter. And I give the minus sign basically since I am choosing this is my origin, and finally it's moving towards the negative y direction. It is strike the point which is below my origin. which is towards the negative y direction. So that's why I using the y would be minus 1.9 into 10 to the 2 meter. Now I'm going to plug in this value into my equation, and t is actually the total time it take to come from that point to that, from that point to that point, which is, I can say this is time of flight, because at that time it would be in the flying mode. So then I will write minus 1.9 into 10 to the power minus 2, and it's going to be the y naught 0, v naught yt is 0, minus 4.9 into t square, because 9.8 divided by 2 it will be minus, right? Then I can neglect out this minus sign from here. Then I can find out this t is going to be, if you solve this one, you will find out that t is going to be 0.062 second. That would be actually your time of flight. This is the answer of question number 1. Now the second one, what is the initial velocity? To solve that initial velocity, I will again want to use x equal to x naught v naught xt plus half of ax t square. I am using this equation for the first time for you, so that you can cope up with the system, but in the middle of that problem sometime I will use directly that equation x equal to v naught xt, because I know that along to the x direction the particle will move at a constant velocity. So that's why my acceleration would be 0 and x naught would be also the 0. Then I will find out x would be v naught x into t. I know the x they give us, which is actually the 30, right, 30 meter, and I also know the time it travel in that direction also, which is 0.062, that I find out, which is time of flight actually. Then I can find out v naught x would be x divided by t, that would be 30 divided by 0.062, it would be 480 meter per second. Sorry, it was not a dart, it was actually a bullet. That would be the speed, initial speed. At that speed actually it was thrown.
Sir,
Yep.
so do you have to write like this while solving the problem, or we can just do it like simply?
I did in the simple way. Did I do
No,
in
no,
the
no. Like
difficult
while
way?
solving, you
Sorry, which one we are talking about? You can write
Sir,
down.
I think, sir, he's asking that if
we
we are.
could just like
Yes.
write velocity in vertical direction, like v in vy direction, like this.
I can't hear you. Say it again.
So we could just write like v in y direction, right? So at the beginning of the equation, we could write solving vertically. Then we solve using like v is equals to u plus at, something like this.
Yeah, you can write down that one. But it should
Yeah,
be a
that's
way,
what.
because unless you do not mention that headline velocity in the vertical direction, then I cannot understand which one actually you are
Yes.
considering,
Before
horizontal
writing the
or
equation, we will just write like
vertically.
solving vertically or solving horizontally.
Yeah, you should give that heading. Or otherwise, you
Yeah.
can use that symbol actually.
Because
But
I find it confusing while writing like this.
no, no, no,
That's
no, no. This is not confusing. This is not confusing. You have that idea, which is actually because I'm velocity indicating in any direction, right?
Yes, sir.
Yeah, cope up with that system. It will be help you a lot.
Okay, sir.
Cope up with that system,
Sir.
because yes.
So I still have one type of question, sir,
Go ahead.
on this topic, sir.
Go ahead.
So, for example, you have said about sir, this type of figure, sir. Sir, I have, for example, I have thrown a bullet from here, sir. It hits the wall, and after hitting wall, it goes inside certain centimeters, sir. For such cases, sir, how can we find the total distance covered by the bullet, sir?
Yeah, that could be solved. I'll come to that point.
Yes,
Don't
sir.
worry.
Thank you so much, sir.
First, I'm going to solve this another type of problem over here, because that time I don't. Last 1 minute, guys. Give your attendance right now. Just write down your ID. Only the ID. Do not write anything else. Right, so time is up, I think. Let's talk another case. Actually, so this is a case, a problem. You throw a ball with a speed 25 meter per second at an angle 40 degree above the horizontal directly towards a wall which is 22 meter apart from your releasing point of the ball. Then how long does the ball take to reach the wall? How far above the release point does the ball hit the wall? What are the horizontal and vertical component of its velocity as it hit the wall? When it hit the wall, has it passed the highest point on its trajectory? This is a very interesting case. Say this is the case I'm drawing for you. So this is a wall, and you throw that ball from here with the initial velocity, say that 25 meter per second, making an angle. Let's give the 40. Now this, the distance from the wall from you actually 22 meter. Now the ball will follow that, say that trajectory. This is the trajectory. It's going to this right. Now first question, how long does the ball take to reach the wall? What do you understand this question? What they are asking from this one? What parameter should I find out from there?
So horizontal velocity, then
How long does the ball take to reach the wall?
22 divided by 40 cos 25. No. Yeah, yes. 22 divided by cos 40 into 25.
Cos 40 into 25. Yeah. So now don't think about my intention to ask this question. If you think about, they are asking for to find out time to reach its maximum height. If someone think about that thing, that's not going to work for you, because you do not know when you throw that ball, when it strike the wall, it was in its highest point on its trajectory. That question also it asks. When it hit the wall, has it passed the highest point of its trajectory, or it was on its highest point on its trajectory? I do not know that one. If it is not in the highest point on its trajectory, then I cannot use that formula, time to take to reach at the top point, which is the TR. Right? Excuse me. Right, I'm sorry. So that's mean I cannot say actually, because that information is not given into the question. If I am not sure about that, the particle when it strike the wall, it was on its highest point of its trajectory, then I cannot use that equation T up. That's not going to work for me unless I'm not sure about that. That information is not given into that equation, so that's why I'm not going to use those equation over here. Look at this. I can say it should be basically its time of flight, or I can use my general equation. I can find out this component of this velocity, say that v naught x would be v naught cos theta, which would be basically 25 cos 40 degree, which is 19.2 meter per second, and v naught y, which is v naught sin theta, is going to be 25 sin 40 degree, which would be 16.06 meter per second. Then I know the horizontal displacement that is given. I will use my equation x equal to x naught v naught xt plus half of ax t square. This one will be 0. This one will be also the 0. Then I can write the horizontal direction it will move at a constant velocity, which equation will be x equal to v naught x into t, right? Then I know the x, which is actually 22. I know the v naught x, which is 19.2 into t, the time it take to reach the wall. Then I can find out the t would be 22 divided by 19.2. It will be give me 1.15 second. So that means after throwing 1.15 second later, it will strike the wall. So that would be the answer of the first question. How long does the ball take to reach the wall? I can write this would be my t would be 1.15 second. This is the answer of the first question. All right. Now the second question, how far above the release point does the ball hit the wall? How far above the release point, because this is actually your release point. How far above the release point? That means they are asking to find out that height. The y, I use the y, not the h. I use in that way. So, but right now again I cannot use my maximum height formula over here because I am not sure about. So, if you want to find out the t up, you can check that what would be your t up equation. T up actually would be v naught sine theta divided by g. That formula you have to use, right? You can check that one actually. So, whether it's going to be cross or not, or while it strike the ground, strike the wall, was it in on its highest point in its trajectory. V naught sine theta is what? Which is 16.06, right? If I 16.06 divided by 9.8, it become 1.6. So t up means 1.63 second. But when it strike the wall, which is 1.15 second. So that means it will strike the wall before it reach its maximum height. Because to reach at that velocity with that angle, it will take 1.63 second to reach the maximum height. But when it strike the wall, which was 1.15 second. So that means before reaching its maximum height, probably if this wall is not present, it will go a little bit of there. That would be its maximum height, right? So that's how I am showing you. So you don't have to check that one. You can use this equation directly without checking this thing. So if you solve this in general way. Now I will use my that formula. So my maximum height formula is not going to work over here. So I'll write in that case y would be y naught v naught t plus half of a y t square. I know everything over there. So I can find out this vertical displacement. Y naught would be 0. It says 16.06 into time to reach that wall, which is 1.15 minus 4.9. 4.9 basically half into 9.8. So that's become 4.9, and t is 1.15 square. If you solve this one, you will find out that y would be 11.98 meter. So that would be that releasing point. So that's mean the ball will be strike the wall above 11.98 meter from your releasing point. This is the case. And second case, what are the horizontal and the vertical component of its velocity as it hit the wall? So when it hit the wall, just before it hit the wall, I know it has the two velocity. One is the x, another is the y component, right? This will be your y component. Vx, I can find out that will be remain same throughout its journey because it moves at a constant velocity. That would be v naught cos theta, which actually 19.2 meter per second that I find out initially, right? Which is 19.2 meter per second. This is actually v naught. Now the vy that I have to use, it would be v naught y plus ayt. V naught y, that is actually 16.02 minus 9.8 into 1.15. I'll find out that would be 4.79 meter per second. Right, that's mean well before striking that wall, its total velocity was vx I hat, vy z hat, then it would be 19.2 I hat plus 4.79 z hat. So that would be your total velocity. But unfortunately, sometime I find out, I asked once a case actually in an exam, what will be the total velocity before it was stacked. Someone actually add this, that say that the total velocity is 19.2 plus 4.79, which is 23 point something, 89, which is completely wrong. It's a blunder. You cannot never add these two velocity at a time. 19.2 plus 4.79. You cannot say that it will be 23.89. That's completely wrong. If you write down in that, that's when you don't have any idea about the vector. Go back to school. I give him a suggestion actually. You are not suitable for this level. Go back to again school. So don't do this, that type of mistake over here. So you cannot never add these two component, x and y component. That's the thing actually I discussed in the vector in the 2 weeks. I spent the vector for the 2 weeks, 4 classes. If you do the same type of problem, I'm sorry to say that prescription would be also applicable for you. Go back to school. All right, so this is actually what. Now what about the fourth question? When it hit the wall, has it passed the highest point of its trajectory? Can you answer this one?
So y value is needed, sir?
Y value?
Is needed, sir, to find this.
Y value is needed to find that one, yeah? That's the right track. So look at this. If I say this is the trajectory, this is the at the top point. At the top point, if I draw before reach the top point, this will be my Vx, this will be my Vy, right? At the top point, I have only the Vx. After crossing, just right after the top point, Vx would be this one. What is the direction of the Vy? It would be the downward, right? You understand my point? Just right after the maximum point, the component of the Vy would be downward. Downward means it would be negative, because you choose upward is your positive y direction, downwards would be negative. Since in this problem I find out that my when it strike the wall, still the Vy excuse me, still the Vy component is positive. It's not become 0. That's why it's not in the maximum point. Still is going to the upward direction. If it is cross that maximum point, then definitely that V would be like that, 19.2 I hat minus 4.79 J hat. That was the format if this cross the maximum height, because after crossing the maximum point, Vy become negative. That's why I can say from this question, no. The answer of the fourth question will be the no. It is not. It was not cross the maximum point when it was strike the wall. That's the answer. All right, thank you very much. I'm done with these topics today.
Is answered by the time we have got from A.
Yeah, you can also say that by the time, that one I show you over here in the first case, right? I find out the time to reach the maximum height. You can explain also that in term of time, but I explain with the velocity actually.
Okay, sir.
All right, guys, thank you very much. You have a quiz in the coming Thursday, right? So day after tomorrow actually. And into that, this syllabus is also included, remember.
Assalamualaikum, sir.
Assalamu
Assalamu alaikum.